A degree is a measurement of rotation. It tells you how far you've turned from where you began. So, a full turn around the circle is divided into 360 degrees. Now, an angle is formed when two lines meet at a point called the vertex. It measures how much one line has turned away from the other, and we usually measure these in degrees just like we saw in the circle. There are different types of angles. We have the acute angle, which ranges from 0 degrees to less than 90 degrees. We have the right angle, which is exactly 90 degrees and forms a perfect L shape. We have the obtuse angle, which ranges from larger than 90 but smaller than 180 degrees. And we have the straight angle, which is exactly 180 degrees and looks like a straight line and represents a half turn. So here is a short example of what the unit circle will look like. I'm not going to show the full unit circle yet, but for now I will review why the unit circle is divided into different angles. We know that the full circle forms 360 degrees and we will always have an x and a y axis. So with this we form a circle of 4 quarters. 1, 2, 3, and 4. We start at degree 0 and we move to the first right angle as written in here, 90 degrees, and here we have the straight L shape. Stack another 90 degree angle to the left and we sum 180 degrees, since 90 plus 90 degrees gives 180 degrees. Then add another right angle and we get 270 degrees, and finally 360 degrees. Now, from here, there are more divisions inside each quarter of the circle, but these include angles of 30 degrees and 15 degrees. But why, might you ask? Because these angles will be necessary for the geometry of two special triangles that we will use for most problems later on. But also because this was easier to understand before calculators existed and other angles have more complex values, making problems way more difficult to compute and to solve. So when we zoom into 1 quarter, we can divide it into 3 angles, each of 30 degrees. We start again at 0, go 30 degrees away, then another 30 forming 60 with respect to 0, and another 30 giving 90 degrees. Now we have 3 acute angles inside one big right angle. We also have two 15-degree angles between this 60 and 30 degrees by dividing exactly half. This is a 45-degree angle with respect to 0, and we have formed the first quarter of the unit circle. The good news is that this pattern repeats to the rest of the quarters. As we can see, this goes on to the second quarter. If we add 30 degrees to the 90 degrees, we sum 120 degrees, and then 150 degrees, and finally 180 degrees. The half of 120 and 150 degrees is a 135 degree from dividing this 30 into 2 again, with this angle being now 15 degrees as well as this angle. So knowing how to divide the circle sets our foundation for later using the unit circle to calculate sine, cosine, and other trigonometric functions.